This is the OCR GCSE 9-1 Maths paper 6 covering the higher tier, and it's from the November 2019 series, and it's a calculator paper. Question number 1. We have to solve 3x minus 5 being greater or equal to 10, showing our solution on a number line. Well, if we add 5 to both sides, on the left hand side we'd have 3x, and this is greater or equal to 10 plus 5, which is 15. And therefore 3x is greater or equal to 15, and dividing both sides by 3, 3x divided by 3, that's just x. Then we have the greater or equal then, and then 15 divided by 3, that's 5, so we have x is greater or equal to 5. And now we need to show this on a number line. Well, 5 is over here. So we draw a circle, like so, and then we draw an arrow pointing towards the right, indicating that x is greater than 5. Now here, of course, x is greater or equal to 5, so what we need to do is shade in inside of this circle, as we see over here. So here is the solution to this inequality on a number line. Question number 2. Amrit's income is 32% more than Bethan's income. Amrit and Bethan's combined income is 54,868. We have to calculate Amrit's income. Well, first of all, we will let Bethan's income equal x, and if we do that, their total income will be x plus 1.32x. So here will be Amrit's income, which is 32% more than Bethan's income. And the total is equal to 54868. So we've got 2.32x equals 54868. And therefore, if we find out what x is, we have 54868 divided by 2.32, which is 23650. And therefore, what we can conclude from here then is Amrit's income will equal 23650 times by 1.32, because his income is 32% more than Bethan's. So what we'd get over here, if we times this by 1.32, we'd get a value of 31218. So therefore, we have 31218. Question number 3. Jacob, Amelie and Reuben each roll a fair six-sided dice. What is the probability that all three roll a number less than 3? Give your answer as a fraction in its simplest form. Well, if we think about the different outcomes we can either have a 1, a 2, a 3, a 4, a 5, or a 6. And from here, what you can see is the probability that we have something less than 3. Well, we've got this 1 and we've got this 2 over here. So we've got 2 out of a total of 6, which is 1/3. And therefore, the probability that all three of them get less than a 3, that's equal to 1/3 times by 1/3 times by 1/3, which is 1/27. So we have 1/27 as our probability. Question number 4. The diagram shows two rectangles A and B. We've got rectangle A with dimensions 25 centimeters and 12 centimeters, and we've got rectangle B over here. Rectangle A has a width of 25 centimeters and a height of 12 centimeters. The width of rectangle B is 3 times the height of rectangle B, and the area of rectangle A is equal to the area of rectangle B. We have to find the perimeter of rectangle B. Well, over here, if this is x, this over here will be 3x, and the reason we multiply by 3 is because of this statement over here. So therefore, let's begin by finding the area of A. So for the area of A, we have 12 times by 25, which is equal to 300. So we have 300 centimeters squared for the area of A. And for the area of B, we have 3x squared centimeters squared. Now we know that the areas are equal, so we know that the area of A is equal to the area of B. So what we have here is 3x squared equaling 300. So that's from this statement over here. And therefore, dividing through by 3, we have x squared equals 100, and therefore x is equal to positive 10. Remember, length can't be negative. And therefore, what we have is 10 centimeters here and 30 centimeters here. So for the perimeter, what we can see then, the perimeter is equal to 2 lots of 10 plus 2 lots of 30, which is 80. So we've got 80 centimeters for the perimeter. Question number 5. K invests £1,500 in an account paying 3% compound interest per year. Neil invests £1,500 in an account paying R% simple interest per year. At the end of the 5th year, K and Neil's accounts both contain the same amount of money. You have to calculate R to 1 decimal place. Well, if we consider the situation for K, at the end of the 5 years, he would have 1,500 times by 1.03 to the power of 5. So if we work this out, 1,500 times 1.03 to the power of 5, we get a value of 1738.91, etc. We'll leave this in our calculator for now. And if we consider the situation for Neil, well, the interest, what we'd have here is R% of 1,500, which is equal to R over 100 lots of 1,500, which is 15R. So this is the interest per year. How does this help us? Well, in 5 years, what we'd have is 5 times by 15R, which is 75R. So here is the interest over 5 years. And therefore, the total amount he'd have would have the original 1,500 plus 75R. And if they have the same amount of money, this is equal to 1738.91, etc. So this comes from the fact that they both contain the same amount of money after 5 years. And now what we will do is use this information to calculate what R is. So if we first of all subtract 1,500 from both sides, we have 75R equals 238.91, etc. And therefore R, if I divide this by 75, we get 3.185, etc. And what we need to do now is round this to 1 decimal place. Of course, you'd find over here R is equal to 3.2 to 1 decimal place. Question number 6. The table shows the children nominated to win the subject prize in mathematics and the subject prize in English. And that's what we see here. And the winner of each subject prize is picked at random. It is possible for Alice to win both prizes. In what percentage of the combinations of prizes does Alice win at least one prize? Well, let's write out our different combinations. We can have Alice in maths, Alice in English. We can have Alice in maths, Claire in English, Alice in maths and Gabby in English, or we can have Alice in maths, Simon in English, or we can have Ben in maths and Alice in English. That's another combination we can have. Or we can have Ben and Claire, Ben and Gabby, or Ben and Simon. Or we can have Emma and Alice, Emma and then Claire, Emma, then Gabby, then Emma and Simon. Then we can have Paddy and Alice, Paddy and Claire, Paddy and Gabby, and Paddy and Simon. So what you can see here is there's 16 different combinations. So let's just write that down. There are a total of 16 different combinations, and if we think about the different ways Alice can win at least one prize, well, we've got here 1, 2, 3, 4, 5, 6, 7. There's 7 different ways Alice can win at least one, so therefore the percentage is equal to 7, so we just count it over here, divided by 16. So of course, for a percentage, multiply this by 100. 7 divided by 16 times 100, we get 43.75%. So we have 43.75%. Question number 7 of part A, we have to complete the table for y equals x squared minus 4x plus 1. Well, you can see if we substitute, well, what we'll do actually, you can see we're going from minus 1 to 5. So if we go to the table feature on our calculator and key in x squared minus 4x plus 1, we start at minus 1, finish at 5. So you can see here we've got 6, here we've got 1, here we've got minus 2, here we've got minus 3, then we've got minus 2, and then we've got so we've got minus 3, minus 2, and then here we've got 1, and then here we've got 6. So now for part B, we have to draw the graph of y equals x squared minus 4x plus 1, where x is in between minus 1 and 5. Here we've got the graph of y equals x squared minus 4x plus 1. Now for part C, we have to draw the graph of 2x minus 6, in between minus 1 and 5. You can see here when x is equal to minus 1, y is equal to minus 2 minus 6, which is minus 8. And when x is equal to 5, we've got 10 minus 6, which is 4. So it goes through minus 8 and 4. So if we draw that graph, you can see here we have the graph of y equals 2x minus 6, as we see here. And now for part D, we have to use the graphs to solve the equation x squared minus 4x plus 1 equals 2x minus 6. All we have to do here is simply look for the intersection points. So we've got one intersection point over here at 1.6 and another one here. If we try find that more accurately, we've got another one here. So we've got here x equals 1.6, and we also have x equals, well here we've got 4.4 essentially to one decimal place. So those are our solutions. Question 8. An octahedron is formed from two identical square base pyramids. The square bases are stuck together as shown, as we see here. The volume of the octahedron is 60 centimeters cubed. The length of the side of each pyramid's square base is 5 centimeters. And we have to work out the height h of the octahedron. We're given that the volume of a pyramid is a third times by the area of the base times by the perpendicular height. Well, if the total height over here is h, that means that the heights here will be h over 2, because h over 2 plus h over 2 gives us h as we see here. So what we need to do is find out what h is. Now, the volume of the octahedron is 60 centimeters cubed. So that means the volume of this and the volume of this added together gives us 30. Rather, gives us 60, so each volume is equal to 30. So we've got 30 centimeters cubed here and 30 centimeters cubed here. So how does this help us? Well, to work out the volume of a pyramid, we've got a third times by the area of the base. Well, the area of the base here, if we've got a square and each side is 5 centimeters, that means we'd have here the area of the base being 5 squared. I'm going to times this by the perpendicular height, which we said is h over 2, and the result of this is 30. So what we have over here is 25 h over 6 equals 30. So 25 h is equal to 6 times by 30, which is 180, and therefore h is equal to 180 divided by 25, which is 7.2. So we've got h equals 7.2. So let's just add this here. We have 7.2. Question number 9 for part A. Well, we're given that vectors a is equal to 3 minus 1 and b is equal to 1, 3. We have to find the value of k and n such that k lots of a plus b equals 10 over n. Well, if we actually work out what the vector a plus b is, we have the vector a 3 minus 1 plus the vector b, which is 1, 3. So it turns out here we have 4, 2. So what we have then is k lots of a plus b, so we've got k lots of 4, 2 equals 10 n. So we've got 4k equals 10 if we look at the top components, and therefore k is equal to 10 over 4, which is 2.5. And then we've got 2k equals n, and therefore n here is equal to 2 lots of k, so we've got 2 lots of 2.5, which is 5. So we've got 2.5 and 5. And part B, Gavin starts to draw a diagram to show that a plus 2b equals 5, 5. We have to complete Gavin's diagram. Well, if we take a look over here, what we have is, here we're going 5 this way and 5 this way. So here is the vector 5, 5. And if we take a look at a, well, we know that a is equal to 3 minus 1. So first of all, you can see that here we have a plus 2b, and then we've got the 3 minus 1, so 3 across, that's going 3 across here, and then we go 1 down, like so. So going in this way, we have the vector A. And then for the vector B, that's 1 across 3 up. So the vector B, that's 1 across 3 up. So from this point here, if we go 1 across and 3 up like this, here's the vector B, and what we have is essentially twice that. So here we've got the vector 2b, and therefore here is our complete diagram. Question number 10. 9 consecutive numbers are written on a 3x3 grid. They are arranged in ascending order in a spiral as shown, as we see here, and Karen writes the numbers 3 to 11 on her grid, and the total of the first column is 3 plus 10 plus 9 was 22. And then Karen says the total of the first column is 1 less than the total of the second column. We have to show that this is correct for Karen's grid. Well, you can see over here that 3 is 1 less than 4, 10 is 1 less than 11. So that's for the... Rather here, what we're doing is looking at the total. So the total for the first column is, as we were told, 22. So total for the second column would have 4 plus 11 plus 8, which is 23. So here is the total for the second column, it's 23. And what you can see is this is indeed 1 less than what we have. So 23 take away 22, that's equal to 1. So we've got 1 less than, as we see here. So this is for the second column, this is for the first column. And that's exactly what we wanted to show. Now for part B, Victor says, if any 9 consecutive numbers are arranged in ascending order in this spiral on a 3x3 grid, the total of the first column will always be 1 less than the total of the second column. We have to prove that Victor is correct. Well, what we're looking at is any 9 consecutive numbers arranged in consecutive order. Well, here we start off with 3, then we go to 4, then 5, then 6, then 7, then 8, then 9, then 10, then 11. Now, what we're doing is we're starting in the top left, okay? So if we take a look at the situation for the first column, for the first column, well, if our first number is n, okay, so if this 3 here was n instead, well, we're starting off with n, then the next number over here, you can see to go from 3 to 10, that is another 7. Now let's think about it. We've got 1, 2, so here we've got 1, 2, 3, 4, 5, 6, 7. So to go from here to here, we go 7 places. So how does that help us? Well, what we'd have here then is this 10 being replaced with n plus 7. And then, well, if that's position, well, here we start off with n, then, so let's just actually be more specific. We start here, and then we've got 1, 2, 3, 4, 5, 6, 7, 8. So here we'd have n plus 6 instead of a 9. So we add on n plus 6. So here we'd have 3n plus 13. And if we consider the second column, well, instead of us having a 4 here, we're starting off with an n plus 1. So that's what we have here. And then here we have an n plus 8. And then we have here an n plus 5. And in total, what we'd end up with is 3n plus 14. So, if we find the difference, what we'd have then is 3n plus 14 take away 3n plus 13, which is 1. And that's exactly what we wanted to show. Okay, so if we go back here, just make this clear. We start here, and then we've got our first, second, third, fourth, fifth, sixth, seventh, and eighth, as we see here. So the difference between the second column and the first column is always 1. Question number 11. A sequence is defined by un plus 1 equals 5un minus 15, and if we're given that u3 is equal to 6, we have to calculate u5. Well, over here, what we need to do before anything else is calculate what u4 is. u4, that's equal to 5 lots of u3 minus 15, so we've got 5 times by 6 minus 15, which is just 15. So that's what u4 is, and therefore for u5, we'd have 5 lots of u4 minus 15, so we've got 5 lots of 15 minus 15, which is 60. So u5 is equal to 60. And now we have to calculate what u2 is. Okay, so to calculate u2, well, u3, that's equal to 5 lots of u2 minus 15. Okay. So we have here u3, which is 6. So 6 is equal to 5u2 minus 15. So adding 15 to both sides, we have 5u2 equals 21, and dividing both sides by 5, you will find u2 to equal 4.2. So we have 4.2 for u2. And now for part B, Trevor says if u1 is 3.75, then u100 is 3.75. We have to show that Trevor is correct. So over here, what we can do is, with the sequence, find out what u2 is. So with this, we've got u2 equaling 5 lots of u1 minus the 15. So we've got 5 times by 3.75 take away 15. So if we work this out, we've got 5 times by 3.75 take away 15, which is 3.75. And therefore u3 will equal 3.75, u4 will equal 3.75, and we could go on. All the terms are the same, so u100 will also equal 3.75. So what we can conclude from here then is, so all terms are equal, and therefore this person is correct. Question number 12. Aaron ran a distance of 5 kilometers at an average speed of 2.2 meters per second. How long did Aaron run for? Give your answers in minutes and seconds to the nearest seconds. Well, first of all, we know that speed is equal to distance over time. So what we can do over here is, well, you'd find here we've got kilometers and here we've got meters. So to go from kilometers to meters, we would have to times by 1,000, and meters to kilometers we'd have to divide by 1,000. So if I times this 5 by 1,000, 5 kilometers is the same as 5,000 meters. So therefore, his time is equal to the distance, 5,000, over the speed, which is 2.2. So let's just keep the units on over here. So therefore, 5,000 divided by 2.2, we get a value of 2272.72, etc. seconds. And we need to convert this into hours and minutes. Rather, we need to convert this into minutes to the nearest second. Well, to go from minutes to seconds, what we'd have to do is times by 60, and seconds to minutes we'd have to divide by 60. So if I divide this value by 60, we get 37.87, etc. minutes. And now this 0.87, etc. this value here would have to convert into seconds, so we times by 60. So here we get 37 minutes and 52 seconds to the nearest second. So we have 37.52. Now for part B, Claudine cycled a distance of 5.3 kilometers in 2.7 hours. The distance is measured correct to the nearest kilometer, and the time is given correct to one decimal place. We have to calculate the upper and lower bounds of her average speed. Give you answers to two decimal places. Well, here we've got kilometers and hours, and here we've got kilometers and hours, so there's no need to convert any units. Okay, so what we will do first of all is find out the upper bound of the distance. The upper bound is equal to 53.5 kilometers, and the lower bound of the distance, that's equal to 52.5 kilometers. The upper bound of the time, that's equal to 2.75 hours, and the lower bound of the time, that's equal to 2.65 hours. And therefore, for the upper bound of the time, again, if we use this idea that we mentioned here, speed equals distance over time, we need to divide the distance by, what we need to do is find the upper bound of the speed. So speed equals distance over time. So therefore, what we need to do is, for the upper bound of the speed, we want the top to be as big as possible, the denominator to be as small as possible. So here we have upper bound of distance divided by lower bound of time. So we'd have 53.5 kilometers divided by 2.65 hours. Okay. So we have 53.5 divided by 2.65, which is 20.188,679.25. Write the full thing out. So here we have meters, here we have kilometers per hour. And for the lower bound of the speed, that's equal to the lower bound of the distance divided by the upper bound of the time. So the lower bound of the distance would have 52.5 kilometers, and the upper bound of the time we have 2.75 hours. So if we work this out, we have 52.5 divided by 2.75. It turns out here we get 19.090909, etc. kilometers per hour, and we need to give these two decimal places. So here we have 19.09 and 20.19 as the upper and lower bound respectively. Question number 13. Danny has a pack of 45 cards. Each card is either red or black. 1/3 of the cards in the pack are red. She picks 2 cards from the pack without replacement. We have to calculate the probability that Danny picks 2 black cards. Well, over here what we need to do is first of all find out how many cards are red. So 1/3 of 45, that's 15. So we have 15 red and 30 black. Okay, so how does this help us? Well, if we draw a tree diagram, here we've got the information for the well, let's just draw the tree diagram first. We have either red or black, red or black. Probability that she picks a red, that'll be 1/3, and then 2/3 for black. Now, what we'd have in total, if she already picks a card, would have 44 cards remaining. Okay. And of those 44, how many blacks will she have? Well, she had 30 blacks originally, and therefore should have 29 blacks left over. And we could work out the other branches if we wanted to, but all we need is this and then this. So therefore the probability of picking 2 blacks, that's equal to 2/3 times by 29 over 44. So 2/3 times by 29 over 44, that's 29 over 66. So we have 29 over 66 as our probability. Okay, so that's how we do that question. Question number 14. We have to write the 4th root of 8 to the power of 5 as the power of 2. Well, we know already 8 is the same as 2 cubed. So we've got 2 cubed and then the 4th root of this raised to the power of 5. Now, raising something to the power of a quarter is the same as 4th rooting something. So we have 2 to the power of 3 to the power of 1/4 to the power of 5. So timesing the powers, because we've got base to a power to another power, we'd have here 2 to the power of 3/4 to the power of 5, and then again multiplying the powers, because we've got a base to a power to another power, we'd have 2 to the power of 15 over 4. So we have 2 to the power of 15 over 4. Question number 15. The histogram shows information about the weights of some of the parcels handled by a delivery company in 1 month. And Zoe says there are fewer parcels weighing between 450 and 700 grams than parcels weighing between 300 and 450. Is Zoe correct? Show how you decide. Well, first of all, frequency density multiplied by class width gives us the frequency. So if we consider between 300 and 450, well, we have here a frequency density of 70 and a class width of 150. So here 300 times by 70, rather here we've got 150 because we're going from 300 to 450. So here we get a value of 10500. And here we're going from 450 to 700, so that's 250. And then we times this by 50. So therefore we've got here 12500. So what we can therefore conclude then is, well, between 300 grams and 450 grams, we have the frequency equaling 150 times 70, which is 10500, and between 450 grams and 700 grams, we have the frequency equaling 250 times 50, which is 12500. So therefore, which one is larger? Well, it's the one over here. So what you can conclude then is she is incorrect. And now for part B, the delivery company delivers 6,500 parcels weighing between 50 and 10. So between 50 and 10, we have 6,500 parcels, and we have to complete the histogram. Well, you can see here then that the frequency density is equal to the frequency, which is 6,500, divided by the class width, which is 50. So here we'd have to draw a height of 130 for our bar. So if we do that, so 130, that's over here, then drawing a line across, as we see here, here is our completed frequency density, and well, here's our completed bar. And then for part C, Zoe uses the histogram to calculate the number of parcels between 200 and 250, so between 200 and 250. And we have to explain why Zoe's answer is unlikely to be reliable. The weights of the parcels may not be evenly distributed between 200 and 300 grams. Question number 16. In a diagram, A, B and C are points on the circumference. O is the centre. We've got this angle OAB equaling 15 and BCO equaling 10. And we have to calculate the acute angle AOC. So AOC, the acute one, that's over here. So what's the first thing that we can do? Well, what we'll do is we'll split this up like this. So then this angle over here, okay, let's just get a pen out. This angle over here is equal to this angle over here, which is 15 degrees. And this angle over here is equal to this angle over here, which is 10 degrees. Okay, so we've got 10 degrees and 15 degrees. So that means this angle over here will be 180 take away 2 times by 15, which is 150. So we've got 150 degrees here, and that's because, well, that and that are equal because we've got an isosceles triangle because the radius is equal. Okay, so let's just make that clear. That is equal to that, which is equal to that, which is why we've got two isosceles triangles. And then this angle over here is equal to 180 take away 2 times by 10 divided by 2. Well, no need to divide by 2 actually. We've got 160 over here. And therefore this angle over here, that's 360. Take away 15, rather take away 150. Take away the 160, which is 50. So this angle here is 50 degrees. So that angle is 50 degrees. Now for part B, E, F and D are points on the circumference of a circle. We've got a straight line, GDH. We've got this angle EFD equaling 55 and FDE equaling 43. We have to explain why the angle HDF is 82. Well, what we'll do is find out what the angle FED is. So FED, that's equal to 180 take away 55 take away 43. So we've got 180 take away 55 take away 43, which is 82. So we've got 82 degrees for this angle over here. How does that help us? Well, let's give the reason for this. Angles in a triangle sum to 180, and the angle FDH is also equal to 82, and the reason for this is because of the alternate angle theorem. So let's just write that. So we've got this angle HDF equaling 82 because of the alternate segment theorem. Question number 17. The triangle, we've got a triangle here with vertices A, B and C, and it's enlarged with a scale factor F and centre of enlargement E. A is mapped to 6, 7, so 6 across 7 up, that's over here, so we'll call this point A dash, and B is mapped to 2, 9, so 2 across 9 up, that is over here, so we'll call this point B dash, and we have to find the coordinates of the centre of enlargement of E. Okay, so what we'll do here is we'll match up all the points. So we've got that point matching up with this one, this matching up with this, and here then is where the centre of enlargement will be. We'll call this point E. So this point over here has coordinates 10, 11. And then we have to find the scale factor of F. Well, what you'd find over here is we go from here to here, we go 2 this way, then 2 this way, and then if we go down as well, what we're doing over here is going 4 this way and 4 this way. Okay, so because we are going in the opposite direction, we're getting 2 times bigger as well. So we have a scale factor minus 2. And then vertex C maps to the point R, we have to find the coordinates of R. So vertex C maps to the point R. So if we take a look over here, we've got C to here. Well, that's going 1, 2, 3 this way, and 1, 2, 3, 4, 5 this way. So then we need to go 1, 2, 3 this way, plus another 3, and then 10 down. So that takes us up to here. Let's double check that actually. Let's double check this. So here, well, rather from C to this point, we're going 3 across, 5 down. So then what we need to do is go, if we're stretching that, we need to double this. So here we've got 1, 2, 3, 4, 5, 6, and then 10 down. Okay, I see what I've done wrong. So here, from here to here is 3 across, 3 down. So then we need to go here, 1, 2, 3, 4, 5, 6. And then from here we need to go 10 down, which takes us up to the point 4, 1. Like so. So what we're doing over here then is we're going 3 to the left, 5 down. So here we'd have to go 6 to the left and 10 down. And therefore, you'd find here, we've got the point R. And the point R has coordinates 4, 1. Okay, so that's the end of the paper. Don't forget to like, share and subscribe. And any questions, please feel free to comment them in the comment section below. And hopefully I'll see you on the next video.